seems that my work has disappeared. Okay, so yeah, see how it said it rotates once? Just be aware of that word. Right? It could have said it rotates twice every 40 seconds, and then your period would be 20 seconds, not 40 seconds. Right? And when we talk about period, it's always just one rotation. So it's how long one cycle takes. Period equals one cycle. In this case, it's 40. Now, if you were making an equation, 40 is not the b value. We are kind of making an equation here because it's good practice for us. To figure out the b value, b is 2 pi over 40, which in our case would be pi over 20. These are different things. They're related, but they're not the same. Question C, which will be our d value. The median height. Median means middle. Right, so it's like the mid height. Okay, the other word they could use here is average. They could say the average height when you're on this Ferris wheel is. That's something they could say. We call this the d value. Perfect. To do the midline, I like to do the max plus the min and divide that by 2. Now the max and the min are affected by the size of the Ferris wheel, but also the fact that the Ferris wheel is on a stand. Right? It's said that the passengers get on a point 1 meter above the ground. That means my maximum is 41 and my minimum is 1. And I divide that by 2. Right? The reason I got maximum 41 is the Ferris wheel is 40 big, right? 20 and 20 is 40. And then it's 1 up from there. The minimum would be at the ground, but then it's 1 meter up. My d value is 21. If you think about what I just did, I got a Ferris wheel like this. They're telling me this is 20. This is another 20. This is 1. Right, so my maximum height is 41. Minimum height is 1. I'm right here. Perfect. We could build this equation almost complete. We have an a, a b, and a d value. We currently have this. 20 sine pi over 20 x minus c plus 21. The only thing that you would be missing would be your c value. I believe typically if they provide you a c value, that they give you the graph. Like most of the time they would give you what this function looks like, but we could sketch it ourselves too. So our graph would look like this. I get on the ride right here at 1 meters. Once I get on, my height goes up as I go up the Ferris wheel. I hit the top of the Ferris wheel and it comes back down. That maximum height is 41. I know that I have a midline right through here. we all agreed that that midline was at 21. We also know how long this took us. One cycle took 40 seconds, so this is 0. Down here is at 40 seconds. Are we good with this sketch representing these three things that I did? Here's my cycle, up, down, took 40 seconds total. My minimum height was at 1, my maximum height was at 41, my midline was at 21. Perfect. Since I'm making a sine graph, my C value, I am looking for a point that I cross the midline and then go up. This right here, this green dot, that was my starting point. If I think about an original sine graph, this was at the origin. It was here, right? And a basic mother function. That would be my starting point. Crosses the midline and then goes up. Perfect. C value is a horizontal shift. You got to figure out this distance. How far did that go? That's your C value. Perfect. Your C value perfectly will cut in half your minimum and your maximum. So your minimum is at 0. You got to determine how long your maximum took. The maximum would take how long to get to? Yeah, 20 seconds, right? If it's 40 seconds for one cycle, half a cycle is 20. This C value is perfectly in between 0 and 20, meaning that this C value is a distance of 10. It's perfectly in half in between this thing, which was 20. This thing must be 10. My C value is 10. So if I had to create an equation, it would be y equals 20 sine pi over 20, x minus 10, close all the brackets, plus 21. The size question is, could this be a coast graph? Absolutely, it could be a coast graph. That means this would have been your starting point if it was a coast graph, because it starts at low. Why am I blanking on a coast graph? Yeah, no, it starts at the top. For some reason I was like, no, it starts at the bottom. No, it definitely starts at the top. This would be your graph. So you need to move this back to the y-axis. So your C value would have been 20 if you did a coast graph. Cool. That's building an equation. Typically, that's on the harder end of a type of question. That's also a really good written response question, because they can ask you all kinds of parts, right? Part A, find the amplitude. Part B, explain what the period means, right? Part C, build the equation. Right? They can ask all kinds of questions there. Hello. Hi, how are you? Good. Okay, can I do that towards the end of class? Is that okay? Okay, sounds good. You're welcome. Bye-bye. I was going to say funny things, but then it's on the video, and that's just unprofessional. I'm the epitome of professionalism. Kids got me. Okay, let's do another one. Oh, that's it. That's it for trig problems. I do think that you'll see a question similar to this. They tend to happen at some point on the test. They like to make you build trig equations or at least analyze trig equations. Like, it's pretty standard. Instead of a Ferris wheel, though, it could be like the tire on a car and it moves around, right? It takes 2 seconds for the car to rotate, something like that. Anything that's cyclical, so anything that's just repeating over and over and over again, they can do this. Other things we've seen, temperature is cyclical, right? It's daily and yearly cyclical. So like every day it's cold, sun comes up, gets warm, sun goes down, gets cold, right? It follows the same cycle. Our yearly temperature, January cold, June hot, January cold again, right? Like it follows that cycle. We've seen questions about the phases of the moon, right? That's cyclical. It starts with a new moon, right? It's nothing there. It goes to a full moon, slowly goes back to a new moon, right? That's cyclical. Anything that just makes a pattern of constant repeating could make a sine or a cos graph. So the problem might be something you haven't seen before, but the analyzing it is definitely something you can do. The other one is tide. We see tide questions. Tide comes in, tide goes out. So that's ocean, right? Like the water comes up the beach, goes down the beach. Okay. Let's do some trig identities and trig equations. So we're going to solve trig equations now, or prove trig equations. First one says verify that theta equals 7 pi over 6 is a solution to the trigonomic equation in the domain pi is less than 0, less than 3 pi over 2. Perfect. Verifying. If you get a verify question, that's like gold to you. Verified means just put this into this and check left side, right side. Make sure they equal each other. Please show your work. Don't just throw in your calculator and say, yes, it works. You need to show and demonstrate that you know what verify means. It means substitute it. So you should have this now. 5 sine 7 pi over 6 plus 2 equals 1 plus 3 sine 7 pi over 6. At that point, you could throw it in your calculator. You could also calculate this by hand. Sine means y value. 7 pi over 6 is on your unit circle. Anything pi over 6 is somewhere on your unit circle. So if you look at your unit circle, it's in quadrant 3. So you're going to go all the way around. Your y value down there is going to be negative 1 over 2, I believe. Yeah. So that means this is actually 5 times 1 over 2 plus 2 equals 1 plus 3. This is also negative 1 over 2. Yeah.
What if instead of doing this, we simplified it like a linear equation instead of substituting, and then got negative 1 over 2, and then substituted that back into the unit circle?
That's solving. That's not verifying. When you verify, you have to substitute. Yeah. You haven't done anything wrong, you just haven't done what it asked. So verify is to take your answer, put it in. 5 times negative 1 over 2 is negative 2.5, plus 2 is negative 0.5. On the right side, 3 times negative half is negative 1.5, plus 1 is negative 0.5. Left side equals right side. I have verified this. That's a check mark. That's verifying.
If it wasn't a value that was already on our unit circle, would we just do like Pythagoreans with the unit circle and to figure out?
If it was any other value, say this was like 7 pi over 8, which is not on our unit circle, just throw it in your calculator exactly like you see it.
Okay.
So you calculate 5 sine, whatever the angle is, close bracket plus 2. You can do that right now. It would equal negative 0.5. You must be in radian mode, right? Because this is a radian measurement. Yeah.
Would I lose marks if I didn't include the second step?
No. If you went from here to here, you'd be okay. Because you could have just thrown it in your calculator. But you do need to show this. Like, you need to show they actually equal each other. You can't do this and then say, yeah, it worked. You got to do this and then show the numbers equal. Cool, that's verifying. Remember, anytime you solve anything, you could verify your answer. You got 6 hours on a diploma. I hope you use nowhere near 6 hours on your diploma. But if you do, take the time to verify things. Anytime you solve anything, take your answer, put it into the original equation, see if it worked. Cool. Number 2, determine the exact roots for the trigonomic equation. 2 cos theta minus root 3 equals 0. Perfect. Determine or solve, right? Same idea. So I'm trying to figure out what theta equals. Looking at the equation, your first goal when you want to solve an equation is to determine what type of equation you have, meaning is it linear or quadratic? If it's anything bigger than one of those two, you're probably being asked to do something that's too difficult, so you probably made a mistake somewhere. Or you can just graph it and find the x-intercepts. That's also a possibility. But typically, if we're solving something by hand, it's going to be linear or quadratic. Cool. This is linear. Right? There's no power of 2's here. To solve linear means move everything to the other side. Keep your theta on the left side. Let's start by adding root 3 to both sides. That gives me 2 cos theta equals root 3. I almost have theta by itself. There's that 2 in front, so I got to get rid of that 2 by dividing by 2. That gives me cos theta equals root 3 over 2. Perfect. That is what cos theta equals. That is not what theta equals. Right? Theta is an angle. Cos theta is the x value at that angle when we're talking unit circle. If you look, that is something that should ring like alarm bells. You see root 3 over 2, you should immediately think that's definitely on the unit circle. Other things that'll ring alarm bells to use the unit circle. Exact solutions. If I'm looking for an exact angle, that usually rings alarm bells. Yeah, I need to use my unit circle. This is saying x value for theta of root 3 over 2. You go to your unit circle, you look for x values of root 3 over 2. Perfect. You look in quadrant 1 and you see, oh yeah, I have an x value of root 3 over 2. It's at pi over 6. And you box that up. And this answer is good. We've made no mistakes. But it's not a perfect answer. The reason it's not a perfect answer is because points always exist in 2 spots on the unit circle. There's another spot where the x value is root 3 over 2. So you go back to your unit circle, you go all the way around to quadrant 4, and you see again another x value of root 3 over 2. That one is at 11 pi over 6. Those are both good solutions. The reason they're both good solutions is they told me my solution could be greater than 0 but less than 2 pi, anywhere within 1 spin. Both of these are within 1 spin. Both of these have x values of root 3 over 2. So theta equals pi over 6 or 11 pi over 6. All right, number 3. Determine the general solution for 3 cosecant theta minus 6 equals 0. Let's start with just the solution. Let's just start with solving it. It means we're trying to figure out theta. We can figure out the general solution after. Perfect. All right, look, it's linear. That means get theta by itself. Move everything else over. Let's start with that 6. We have to add 6 to both sides. That then gives me 3 cosecant of theta equals 6. I divide my 3 to the other side. I've got cosecant theta equals 2. Perfect. Cosecant is 1 over sine. Agreed? Perfect. So what we can do is we can replace cosecant with sine if we reciprocate the other side. So it becomes 1 over 2. Reciprocate. If you are like, whoa, why does the math on that work? Cosecant is 1 over sine. You'd have to multiply the sine to the other side, divide the 2 to the other side, and you get over to this. Just if you wanted to see how the math works. That's how the math would work. Or if you just remember reciprocate, that works too. Perfect. I am looking for where my y value would equal 1/2. I go to my unit circle. I'm looking for y values of 1/2. I know it happens in 2 spots. The first spot that it happens is in quadrant 1. It's at pi over 6. The second spot that it happens is in quadrant 2. It is at 5 pi over 6. Right, so I looked at my unit circle. I looked for y values of 1/2. Okay. These are solutions. These are not the general solution. Notice they gave me no boundary. They never said solve for theta within 1 spin. General solution means infinite spins. I want all coterminal angles. To determine that, you take your solution, you add a spin to it, you multiply that spin by n, and you say n is an element of the integers. That's what turns us from a solution to a general solution. Here's my answer. I could then spin as many times as I want and keep getting to the same spot. N represents how many spins you choose to do. You can choose any number of spins, as long as you choose an integer spin, meaning it can't be a decimal. This includes negative spins. Integers can go backwards. I would do the exact same thing for my second answer. There are my 2 equations. Sometimes you can combine the general solutions into one. Not always, but sometimes. For instance, say if your solutions were on the x-axis. One here, one here. Then what I could say is the answer is 0 radians plus half a spin times n. Plus half a spin, plus half a spin, plus half a spin. And instead of doing 2 pi, I can just do pi. So you might see something like that. It's like a trickier general solution. Okie dokie, number 4. Solve the following trigonometric equation. So solve. That means I need to figure out what theta equals. First thing I do is I check to see what type of equation I have, because that decides my strategy here. I have a quadratic this time. When we did this on our unit test, the quadratic threw a lot of people for the loop. This thing, quadratic. Wait, I'm going to write it over on the right side. That is a quadratic. When I see that I have a quadratic, I need to make it equal 0, and then I need to factor. Right, that is our strategy for solving quadratics. Make it equal 0, we call that general form. Then you can factor using diamond method. Looking at this equation, it already equals 0. Beautiful. I can jump right into factoring. To factor this thing, I'm looking for things that multiply to be 9 times 4, which is 36, and add to be 12. 6 times 6 equals 36. 6 plus 6 equals 12. Perfect. That means my equation will factor to look like this. 9 sine theta plus 6. Where I got that from? The 9 came from my A value. The plus 6 is the left side of my diamond. I then do it again. Nice. Hope I miss on right over. If it's official. They didn't even turn it on. I don't get it. Maybe it was actually just a mistake. Nope. Try to move. The second one. Because remember, when you factor, you get two binomials. It's 9 sine theta plus 6. It's the same thing. Now, when we factor with an A value, for this question in particular, people might be tempted to put like 9 sine theta plus 6 squared. We're not done factoring yet though, so we can't put that yet. Remember, when you're factoring with an A value, you have to divide this A value out of the equation. So you need to divide one of these binomials by 9. If neither one divides by 9, you need to divide by two numbers that would multiply to be 9. So I need to divide the first one by 3, the second one by 3. That would give me a factor of 9 that I removed, and I now have 3 sine theta plus 6. You could write that as squared now. I'm going to keep them separate because that's what I like to do. It's plus 2, not plus 6. 6 divided by 3 is 2, not 6. Perfect. Next step. You got to solve each one of those brackets. Because they're the same, you really just got to solve one of them. Right? So take one of them and make it equal 0. So I need to solve 3 sine theta plus 2 equals 0. That's linear now. Move the 2 over, divide by 3. That means I have sine theta equals negative 2 over 3. Perfect. I don't like that answer because it's not on the unit circle. But it didn't ask us for an exact value. It should have asked us to round a value because we're going to have to. This is not theta. This is sine of theta. We're looking for theta. That means we're looking for when the y value would be 2 over 3. That doesn't exist on your unit circle. So to find theta, if it's not on your unit circle, you go second sine bracket negative 2 over 3, close the bracket, that will give you theta. Your answer needs to be in degree mode, right? Because it's set up here, we were in degrees. Perfect. When you put sine, second sine, negative 2 over 3, it might give you a crazy answer. What did it give you? Did it give you a negative answer? Yeah.
41.8.
Negative 41.8 degrees? Yeah. I prefer to work with reference angles, which means positive angles. So if I were you, I would put in positive 2 over 3. And it's going to give you the same thing, but without the negative in front of it. It's going to say it's 41 degrees. 41.8, so we'll call it 42 degrees. Now, that would be a reference angle. It's not the theta that solved this equation. That's the reference angle. Theta that solved this equation would be in standard position. We have two different spots where this would happen. It would happen down here or down here. And what we just solved was that in here, on both of them, that distance is 42 degrees. That angle. We want the standard position angles. The standard position angles start here and go around. Start here and go around again. Those are the two angles we're looking for theta. We're looking for this blue one and this green one. The blue one would be 180 plus 42. The green one would be 360 subtract 42. Right? Your calculator will only give you reference angles. That's what it's going to calculate for you. You then determine the standard position angles that would solve your equation. I went a little fast on why that's the two quadrants I was in. I'm in those quadrants because sine, the y value, had to be negative. Right? That's why I built those two quadrants. That means my answer is 222 degrees and 318 degrees. Yeah, Messiah.
When we're given a sine value, how do we know if it's just the y or if it's y over r?
It's technically both. Like when I say it's the y value, that's assuming unit circle, which is assuming r is 1. Right? So like if it's just like the scale that you're putting on r. If I wanted to build the triangle, if I wanted to actually sketch this, then I would call that y and that r, because then it makes an easier triangle. It's -2 and 3. If I made this y, that means r is 1, and then I have a y value that's a fraction, which would kind of suck. Right? So I guess the answer is it's kind of both. Let's just say if it's not on the unit circle, then it's y over r. If it's on the unit circle, it's just y. Technically, though, like when I'm talking, hey, it's on the unit circle, we do know the r value on a unit circle. It's 1. right, next one. The solutions to the equation cos squared x equals cos x are. Two ways to do this. One way, you can just verify these answers. Right? Throw it in left side, right side, see if it works. That's legit. I don't think you'll get a question that easy. Right? So the question that you'd probably see would be like the number of solutions to this equation. Right? And then you can't really guess it. But if they ever give you answers, you can just verify them. All right, pretending they didn't give us the answers, and we want to solve this thing. We're going to solve this. Solutions. That means I'm figuring out what x equals. First thing I do is I check to see what type of equation I have, because that's going to change how I tackle a question. If it's linear, I move everything to one side that has an x. I move everything to the other side that doesn't have an x. If it's quadratic, I have to make it equal 0, then factor. This is quadratic. It might not look like a regular quadratic, but I see that squared, and that screams quadratic. So I'm going to take this equation, I'm going to try to make it equal 0, then I'm going to try to factor it. You can do both those things. So to make it equal 0, I would subtract cos x from both sides. That gives me cos squared x minus cos x. Those are not like terms. Those things cannot go together. That's like saying x squared minus x, right? Those two things could not go together. Cool, I got a quadratic, made it equal 0. Now I need to factor it. People get that. And they forget how to factor it. And they try to diamond method it, because we diamond everything, right? So people try diamond methoding it. You can't diamond method that because it's not 3 terms. It's only 2 terms. Next thing they try is difference of squares. They square root both things, because like, oh, okay, it must be that. You can't difference of square this, because you can't square root cos x. All you need to do here is a greatest common factor. I could divide both those things by cos x. That would leave me with a cos x and a minus 1. And now I have factored. Once you factored, you just have to figure out what would make each one of these equal 0. I like to do it kind of on the side usually, so let's do the first one. Let's figure out what makes cos x equal 0. That means when do you have an x value of 0? On your unit circle, you have an x value of 0 at the top of your unit circle, an x value at the bottom of your unit circle. That's when you have x values of 0. That would be pi over 2 and 3 pi over 2. Are we good with that? We're looking for x values of 0. If you wanted, you could do second cos 0 in degree mode. It would be 90 degrees, right? So I would give you your first reference angle, 90 degrees. Second one would be standard position, would be at the bottom of your unit circle. The other one I have to solve is cos x minus 1 equals 0. Move the 1 over, that means cos of x equals 1. I am looking for cos, which means x values, of 1. I go to my unit circle. That means I am on my x-axis. That would be a value of 0. Technically, you could also spin all the way around and you're back on your x-axis. And that would be at 2 pi. That's where your boundaries become very important. Your boundary said that you cannot equal 2 pi. It said you had to be less than 2 pi. So that answer does not count. My solutions are 0, pi over 2, 3 pi over 2. 0, pi over 2, 3 pi over 2. The answer is C. D is probably the trickiest answer. All those values work. If you verified them, they all would work. 2 pi is not in our boundary, though. You have to be less than 2 pi. You cannot equal 2 pi. I was allowed to equal 0. Equal 0. So that one's okay. Be very careful on your boundaries. That's mean. There you said? That is mean. And that's why I think that would be a good, like, the number of solutions question. Because then they're going to make sure that you're just, like, looking for that particular info. Very subtle info. Cool. The expression cos x over 1 minus 2 sine x is undefined when the values of x are undefined. We saw this on our unit test, but instead of the word undefined, they said NPVs. Same thing. Something's undefined or it has NPVs. And then people looked at it and they were like, NPVs of a trig function? Like, I don't know what that means. What are NPVs? On a regular question, how do we get NPVs? Uh-oh. We'll blame Blinky for this. The 20-1 thing. I didn't teach any of you 20-1. I'm just kidding. I taught like half of you 20-1. Chalky.
They're non-permissible values.
Yeah, non-permissible values. How do you get them? Where do they come from? Like mathematically, what creates an NPV? Yeah, Messiah.
The denominator equals 0.
Yeah, it can't divide by 0. So NPVs, non-permissible values, yeah, they're undefined things. They happen when you divide by 0, because you're not allowed to do that. So to figure out your non-permissible values for a trig function just means that bottom can't equal 0. Solve that. Move the 1 over, divide by -2, solve that thing. So subtract 1 from both sides. That means -2 sine x cannot equal -1. Divide by -2. That means sine x cannot equal 1 over 2. That means you cannot have a y value of 1/2. So you go to your unit circle and you check, when do I have y values of 1/2. When you do that, you'll see that there's 2 spots that you cannot have. You cannot have pi over 6. That's in quadrant 1. And then you look over in quadrant 2, you see another y value of 1/2. It's at 5 pi over 6. Now you'll notice this question never gave us boundaries, which means there's infinite non-permissible values. Right? Just keep spinning around. So your answers have these plus minus things in them because they're general solutions. Our general solution would be pi over 6 plus or minus any spins, or 5 pi over 6 plus or minus any spins. The answer would be A. I don't know why they didn't put a plus minus on A. And they didn't define what n was, which doesn't make me a very big fan of those answers. I think a better way to write the answer would look like this. but then they define that n is an integer. That's a better solution. That's how it would definitely look on a diploma. They might put plus minus instead of just plus, just saying that you go positive or negative, and then instead of I, they might put W, because then you could just do whole numbers. But I do think this is probably how it would show up. My apologies. I'll probably edit that. We okay with that? Denominator can equal 0. Just solve what would make that denominator 0. That's the answer. Okay, trig proofs. Verify that this is true. Verify means put this in for theta in all the spots. It's in angles, so make sure your calculator, it's in degrees, so make sure your calculator is in degree mode. So this would be secant of 30 degrees over tan 30 degrees plus cotan 30 degrees equals sine 30 degrees. Now, if you look at it and you can't find, you panic on your diploma. You're like, I can't find secant or cotangent on my calculator. Don't panic. You know what secant is. You know what cotangent is. Secant is 1 over sine. That cotangent is cos over sine. Both are on your formula sheet. So to put it in your calculator, you put 1 over cos 30. That's what secant is. Divide by, in the denominator, you do have a tan 30 that you can put in your calculator, plus cotangent 30. You might not know what cotangent is on your calculator, but you do know that cotangent is cos 30 over sine 30. And that you can put in your calculator. When you do that, I would suggest that you use brackets around your fractions, right? So there'd be a bracket here around that fraction. There'd be a big bracket in the denominator, and I would even do brackets around that fraction. So I'd have all kinds of brackets. You should end up with 0.5 equals 0.5. That is verified. Left side does equal the right side. Yes, sir.
So if you just did that much amount of work where you showed the equation you put into your calculator with the brackets, that's all you need to do and then show the answer?
Bingo.
Okay.
Verify, if you see verify, that's probably the best type of question you can get. It's just asking you, can you put that in your calculator and make sure both sides equal each other? They might not always equal each other, right? So you could verify that it doesn't work. So if I got 0.2 equals 0.5, you'd say the solution does not work, right? It's not the solution. Okay, this guy. Consider the identity 1 minus cos theta over sine theta equals tan or over 1 plus cos theta. What are the non-crystal values? It means when are we dividing by 0? Divide. What would make you divide by 0? Different places that we need to look. That means right here, sine theta can't equal 0. Second spot. That means this right here, 1 plus cos theta. Cannot equal 0. We got to solve both of those. There's a third one. What's the third division that I have in that question? Sneaky.
That cos theta can't equal 0?
Yeah. The reason why is because tan is really sine over cos. That means cos theta cannot equal 0. Remember that tangent has lots of non-parenthetical values. Remember, like our tangent mother function, there's all those vertical asymptotes. Those are non-parenthetical values. The reason those exist is because tan is really sine over cos. That means cos cannot equal 0. You're going to solve all three of those things. The first one, that means y values can't be 0. That happens at 0 degrees. Happens at 180 degrees. Happens at 360 degrees. Right? Y value of 0. Right at the start of the unit circle, you go to 180, you're at 0 again. You go to 360, your y value is 0 again. Those are all the spots where y value is 0. We go to the cos one. I subtract my 1 over. That means cos of theta cannot equal -1. That's x values cannot equal -1. That happens in one spot. The x value is -1 on the x-axis in between quadrant 2 and 3. That means theta cannot equal 180 degrees. And then we get the purple one. That's x value cannot be 0. That happens in two spots. That happens at 90 degrees. Then around your circle, at the bottom of your circle again, at 270 degrees. My non-parenthetical values, if I was to write them all together, would be 0, 90, 180, 270, 360. My boundaries were allowed to equal 0. They were also allowed to equal 360. So that is all my non-parenthetical values. Almost finished Trig. We'll finish Trig tomorrow. Trig takes a long time.